Something happened in Linux gaming during the first quarter of 2026 that, for a specific category of games and a specific kind of player, has changed the relationship between Linux and the console platforms that Linux has historically been unable to compete with. The change is a feature that is now available on Linux, and that is, as far as any public information indicates, not available on any Xbox console, and cannot be made available on any Xbox console because of the specific architectural decisions Microsoft has made about how Xbox works. The feature is, in technical terms, real-time kernel preemption combined with a set of gaming-specific optimizations that allow Linux systems to achieve input-to-display latencies that are measurably lower than what Xbox can deliver on comparable hardware. In practical terms, this means that competitive gamers, speedrunners, fighting game players, and other gamers who care about the small fractions of a second between input and response can now get a better experience on Linux than they can get on Xbox. The gap is not enormous. It is measurable, consistent, and real. I want to walk you through what the feature is, why it produces the advantage, what kinds of gaming it specifically benefits, and why Xbox, as a product, cannot easily match it. Let me start with the specific feature, because the technical detail is the foundation for understanding the advantage. The Linux kernel, as I have covered in other videos, gained full real-time preemption support in the first quarter of 2026, with the mainlining of the Preempt ERT patch set. Real-time preemption means that the kernel can guarantee bounded response times for high-priority tasks. Combined with the sched deadline scheduler, which the kernel has had for longer, and with specific gaming-focused kernel configurations that distributions like CatchyOS and Nobara ship, Linux systems can be tuned for gaming in ways that produce measurably lower input-to-display latency than general-purpose Windows or console configurations. The specific path from input to display on a modern gaming system involves several steps. The input device registers the input. The input is processed by the operating system. The game reads the input. The game updates its state. The graphics pipeline renders the new state. The rendered frame is sent to the display. The display shows the frame. Each step has its own latency, and the total latency is the sum. For a competitive game running at 60 frames per second on a 60 Hz display, the theoretical minimum latency is about 30 milliseconds. A poorly configured system can have much higher latency, sometimes exceeding 100 milliseconds, which feels sluggish to a trained player. A well-configured system can approach the theoretical minimum. On Xbox, the latency is bounded by the design of the console. The operating system that Xbox runs is a derivative of Windows, and it includes the Xbox-specific runtime layers that handle the controller input, the game launcher, the social features, and various other services. Each of these layers adds latency. Microsoft has optimized the Xbox platform to minimize this latency, but the architecture of the platform means that certain latencies are difficult to reduce further. The Xbox controller, which connects wirelessly by default, adds its own latency. The Xbox system software, which has to support a wide range of games and features, is not configured for the extreme low latency optimization that dedicated PC gamers can apply. On Linux, the latency can be pushed lower because the entire software stack can be configured for gaming. Kernel parameters can be tuned. Unnecessary services can be disabled. The scheduler can be configured for real-time workloads. Input devices can be connected through low-latency interfaces. Displays can be driven at their native refresh rates with minimal processing. The result is a system where the total input-to-display latency can be, depending on the specific hardware and configuration, 10 to 20 milliseconds lower than on an Xbox console with comparable hardware. For competitive gaming, this is meaningful. The specific kinds of gaming that benefit from this are those where small timing differences matter. Fighting games, where combos depend on frame-perfect inputs. Competitive first-person shooters, where the time between seeing an opponent and firing is part of the skill. Rhythm games, where timing is the core mechanic. Speedrunning, where the runs are optimized at the millisecond level. Retro games, which were originally designed for displays that had essentially zero latency, and whose original feel depends on matching that responsiveness. For these kinds of gaming, the Linux advantage is directly relevant. For other kinds of gaming, the advantage is less relevant. A casual player of a single-player game does not notice the 10 or 20 milliseconds. A player of a slower-paced game does not benefit. The advantage is specific, not universal. I want to be honest about that. The claim is not that Linux is better for all gaming. The claim is that Linux is better for specific gaming, and the specific gaming it is better for is gaming where latency matters. Now, why can Xbox not match this? The reasons are architectural rather than reflective of any failure of engineering on Microsoft's part. Xbox is designed as a consumer product. It is configured for the widest possible audience. It includes features that general users want, including social features, background download, achievement tracking, streaming integration, and various other services. Each of these features has costs in terms of latency, even when the user is not directly using them. The Xbox operating system is not tunable by the user in the way that Linux is tunable. The user cannot disable the unnecessary services, cannot reconfigure the kernel, cannot optimize the scheduler. The platform provides the configuration that Microsoft has decided is appropriate for the mass audience, and that configuration is not the lowest latency possible configuration. Microsoft could, in principle, add a competitive gaming mode to Xbox that strips out the services that add latency and configures the system for minimum response time. The company has added various gaming-focused features over the years, and a competitive mode would be conceivable. But the mode would need to be designed carefully to not break the user experience. And the actual latency reductions that Microsoft could achieve within the Xbox architecture are limited by the architecture itself. The Linux gaming optimizations are possible in part because Linux is configurable in ways that Xbox is not. There is also a question of hardware. Xbox hardware is consumer-grade gaming hardware, selected for a specific price point and a specific performance envelope. Linux can run on arbitrary hardware, including hardware that is specifically designed for low-latency computing. The high end of Linux gaming hardware includes displays with 1 millisecond response times, input devices with sub-millisecond polling, and configurations that are optimized to extreme levels. Xbox's hardware is good, but it is not that end of the spectrum. The specific applications of this advantage for gamers who care about it are various. Esports players who have the discipline to measure and optimize their setup can achieve response times that were not possible on consoles. Fighting game players can execute timing-sensitive techniques more reliably. Retro gamers can achieve the authentic feel of original hardware. Rhythm gamers can maintain scoring that depends on precise timing. For the broader Linux gaming community, this advantage is one of several developments that have reshaped the comparison with consoles over the last few years. The Steam Deck, Valve's Linux-based handheld, has demonstrated that Linux gaming can be a polished consumer product. The Proton compatibility layer has made the Steam library largely playable on Linux. The driver support for modern graphics hardware has reached parity with Windows in most cases. The ecosystem of native Linux games has grown. The combination of these developments has moved Linux gaming from niche to credible, and the latency advantage for competitive gaming is one of the specific points where Linux now has an advantage over alternatives. For users who are considering Linux for gaming, the practical implications are several. If you are a competitive gamer who cares about latency, Linux is worth evaluating. The specific configuration takes some effort, but the tools and documentation are good, and the result is measurably better than what other platforms offer. If you are a casual gamer, the latency advantage is not a reason to switch, though other advantages of Linux gaming may still be compelling. If you are a gamer with a broad mix of preferences, the decision depends on which games and activities matter most to you. For the broader question of where gaming is going, this development is another data point in favor of the conclusion that platform diversity is increasing. Xbox, PlayStation, Nintendo, PC Windows, PC Linux, and mobile platforms all offer different experiences with different strengths. Linux is now, for certain gaming use cases, the best of these options. That was not true 5 years ago. It is true now. The shift does not mean that Xbox is failing, or that consoles are obsolete. It means that the space of viable gaming platforms has expanded, and that gamers have more options than they used to. For Microsoft specifically, the Xbox latency disadvantage compared to high-end Linux is not a strategic crisis. Xbox is not trying to serve the competitive gaming enthusiast market exclusively. Xbox serves a mass audience, and the mass audience does not care about 10 or 20 milliseconds of latency. The brand can absorb this specific competitive gap, but the pattern of Linux having specific advantages in specific areas is one that is replicating across many dimensions, and the cumulative effect is that Linux is no longer a platform that can be dismissed by mass market companies. Subscribe for the next video, which is a detailed walkthrough of how to configure a Linux system for minimum input-to-display latency, including kernel parameters, scheduler configuration, display settings, input device selection, and the specific benchmarks that let you verify the configuration is working. And in the comments, tell me what kinds of games you play, and whether latency matters for your gameplay. The advantage I described is not universally relevant, and the specific questions of whether Linux is the right platform for you depend on what you actually play and how.